Section 5.6 is solving exponential and logarithmic equations. So we're going to talk about different types of exponential and log equations and how to solve them. This first one looks similar to our exponential equations that we've solved in the past. We have log base 5 of something equal to log base 5 of something. So just like our exponentials where we have the same base raised to a power, we can set the exponents equal to each other. This one you have log of the same base. So you can set the insides equal to each other. So go ahead and pause the video and do that and solve for x. So because this is log of the same base on either side, that means their insides have to be equal to each other. So you get 2x plus 3 equals 3. Subtract 3 from both sides, divide by 2, you get x is equal to 0. The only thing you have to be careful of is there are domain issues for logarithms. If you remember back a couple sections, we said that the domain of a logarithm, what's inside the logarithm, must be strictly greater than 0. So just like when you're solving square roots, by solving it, you're changing the problem a little bit. Here, when we take it out of the logarithm, we're changing the problem a little bit. So we do have to check all our solutions. We need to make sure that if we plug this back in, what you get inside of here is greater than 0. So if you plug it back in, you get 2 times 0 plus 3, which is just a 3, and that is greater than 0, so this is an okay answer. You're good, you can move on. This one's a little bit different because you have a minus in the middle and this 2 on the outside. So like our exponential ones where you had to simplify it down so that you had one term on each side, the same base raised to a power, we need to do the same thing here. So what I want you to do is I want you to pause the video and using our rules from our previous section, I want you to simplify this left side down to 1 logarithm. So I took this 2 out in front and made it an exponent, and then I made the subtraction a division inside. So now we have 1 logarithm, 1 term on this side and 1 term on this side. There is a way that you could make this a logarithm, so you have log base 3 on both sides. Another way to do this is to switch this into exponential form. So go ahead and pause the video and switch this logarithm into exponential form. So your base stays the same, you have a 3, your answer becomes your exponent, and your inside becomes your answer. So you end up with 3 squared is equal to x plus 4 quantity squared over 9. And then this is something that you should be able to solve. So go ahead and pause the video and finish solving for x. So 3 squared is 9, and then I multiplied both sides by 9 to clear out this denominator right here. So you end up with 81 equals x plus 4 quantity squared. And then to get rid of the squared, we square root both sides. Remember, when you take the square root, you need plus or minus. So plus or minus 9 equals x plus 4. Subtract 5 from both sides, you get x is equal to 5 or negative 13. But remember from the previous example, we always have to check our answers to make sure they're within the domain. So go ahead and pause the video and check these 2 answers. So if you check these answers, if you check the 5, plug it into this one here because this one doesn't have any x's. 5 plus 4 is 9. 9 is greater than 0, so that one works. Plug in negative 13. Negative 13 plus 4 is negative 9. That's less than 0, so that one does not work. Go ahead and cross that one out, and it's an extraneous solution. So your only answer is x equals 5. So here's an exponential equation that's slightly different than the ones we've worked on before because of this plus sign in the middle. There's no way to combine things with addition that have exponents, so we need to do this slightly differently. We have this 3 to the 2x here, so we can use one of our exponential rules to kind of work backwards from that. So 3 to the 2x is the same thing as 3 to the x quantity squared. A power to a power, you multiply them. You can actually undo that also. And then I just move this 2 over to the other side. Now what I'm going to do is I'm going to replace this 3 to the x with a different variable. Not x, but something else. So I replace this 3 to the x with an a. Doesn't matter what you pick as long as it's not an x. Every time I saw a 3 to the x, I replaced it with an a. So now I have an a squared plus a minus 2 is equal to 0. This is just a quadratic. We know how to solve quadratics, so we're going to just solve it that way. So go ahead and pause the video and factor this. So this factors into a plus 2 times a minus 1 is equal to 0. So now we can use the zero product property and solve for a. So go ahead and do that. So you end up with a is equal to negative 2 and a is equal to 1. But remember, we're not solving for a, we're solving for x, so we need to undo our substitution and make these a's 3 to the x again. So we have 3 to the x is equal to negative 2, and 3 to the x is equal to 1. So now we want to solve for x. 3 to the x is equal to negative 2. Is there any way I can raise 3 to a power and get a negative number? There's no way I can raise 3 to any power and get a negative number, so that's not going to give you any solutions. On this one, 3 to the x is equal to 1. What power do you raise anything to get 1? So on this one, x is equal to 0. So the solution to this equation is x is equal to 0. So here's another type of exponential equation. This one does have exponents on both sides. There's no addition, but is there any way to write 0.3 as base 1.7 or 1.7 as base 0.3? So probably not, so we can't use our standard way of solving these exponentials. So instead we're going to use logarithms to help us. There's a couple ways you could do this. You could pick one of the two to be your base and switch it into logarithmic form. Or what I normally do is you actually log both sides. So just like you can square root both sides or multiply the same thing to both sides, you can log both sides. It doesn't matter what base you use. I usually use natural log because that's the kind of standard logarithm as you move up in math. So I'm going to natural log both sides. So now you have the natural log of 0.3 to the 1 plus x is equal to the natural log of 1.7 to the 2x plus 1. So now we can use our logarithm rules. You have exponents inside your logarithm, so you can bring those down in front. So make sure you put parentheses around the exponents because you want this whole thing multiplied by the natural log of 0.3 and this whole exponent multiplied by the natural log of 1.7. Remember, natural log of 0.3 and natural log of 1.7 are just numbers, so you can distribute them, you can add, all this kind of stuff. They're just numbers and you can just treat them like numbers. So now, if this was just a 3 and a 7, what would you do to solve this equation? You would probably distribute. So go ahead and pause the video, distribute your numbers, and get all the x's on one side. So we distributed the natural log of 0.3 into the 1 plus x, and distributing the natural log of 1.7 into the 2x plus 1. And then we want to move everything with an x to one side and everything without an x to the other side. So we get x natural log of 0.3 minus 2x natural log of 1.7 is equal to natural log of 1.7 minus the natural log of 0.3. You can't combine these. Well, you can combine them with division, but you don't need to. I would just leave it this way, and same thing here. So now to get the x alone, what we're going to do is we're actually going to factor out this x. So I factored out the x, and so now you have the natural log of 0.3 minus 2 times the natural log of 1.7, and then the same thing on this side that was before. So now you have x times a number is equal to a number. So just like if this was 2x is equal to 7, you would divide by the number that's multiplied by x. Same thing here with this different number, but still just a number. So then I divided both sides by this natural log of 0.3 minus natural log of 1.7, and then this is your final answer. And just leave it that way. Don't plug it in your calculator. You don't need to simplify. You can't cancel the natural logs. That's not possible. You can't just cancel off ln. So this is your final answer. So there's a lot of different types of these logarithmic and exponential equations, and it's just about knowing all your properties, all your algebra skills that you already know. For instance, this example, the only thing that was really new was this logarithmic part, these first two steps. Once you got past these first two steps, all of this was the same algebra we've been doing for years.